So this is going to be a very truncated, kind of semi-quick example. Poor little dude. So everybody hit stat. Oh, let's see. Let's kind of focus there. Hey, look, it's got stuff. All right, sweet. Does that help or hurt? That hurts. Is that this way better or this way better? That's as far down as it goes. How you guys doing? Is this fun so far? Let's see. Okay, over. So edit. Let's get in here. Let's get rid of some of the stuff here. All right, so ready with me. So edit, go to stat, edit. Let's put some data in the list. The whole idea with this linear regression section is I'm going to have two variables. So on that sheet I had the number of beers you had the night before and the grade you made on the test the next morning at 7. Right? That was what that sheet, the first example on the sheet. And we want to see if there's a correlation between the two. Notice this is not, does one affect the other? I don't know which one. Maybe you drank because you knew you're going to do shit on the test. So how you did on the test affected how much you drank. Do you understand what I'm saying? I'm not saying that's what it is either. I just don't know. But I know there might be a correlation between the two of them. There might be some kind of relationship between the two. I just don't know what causes that relationship. This kind of test can't do that. So let's take this data out of here. Get out of there. Get out of there. Let's make up some data. So let's do like, what do you got, Jeff? 78, 80, 89, 91, 120. Everybody good? Yeah, why not 120? And then 152. Those are my favorite numbers. No. Everybody with me so far? Everybody good? Everybody's got L1, L2, L3, by the way, right? Anytime a list dies, just let me know. I have a little service. So let's do this. What do you want, Jeff? Let's do 7, 8, 15, 12, 28, and 39. Kick ass. Before I do anything further, so 7, 8, 15, 12, 28, 39. Is this going to be perfect somehow? Is this going to be perfect correlation?
No.
Hell no. Why not? Immediately, why not?
They're not like ascending or descending.
Yeah, as the x's increase, do the y's always increase?
Yeah.
No. And do they increase by the same amount per how much the x is changing? No. But will this be positive or negative correlation? Because overall, what are the y's doing? As the x's increase, the y's are also increasing. There's a little hiccup there. You guys with me? Okay, sort of like if you're growing and then you have like a rough spot where you get some kind of weird illness or something, you don't grow anymore, and then so there's a little hiccup somewhere. You kind of with me a little bit, all right. But overall, this does seem to have a positive trend because as one variable increases, so does the other in general. And that's what a trend does. What's it seem to be doing in general? Well, this guy did this. I don't care. In general, it's doing that. Let's see. So how do you get all this shit? So I want two things to calculate. I want to get the line that would best fit all those points. And then I want to get a number that represents how strong the relationship is. Those of you who were here last time, is that number going to be close to 1?
Yes.
Yeah, I'd say maybe close. It's only got one place where it hiccuped a little bit. Right? Because what does it mean if it's 1? If the correlation R was 1, what would that mean?
It's positive.
Yeah.
It's strong.
Strong's not even strong enough of a word.
1 is a perfect positive
It's not
correlation.
strong cell, it's perfect cell. It's perfect. Right? Okay. This is not perfect, but it is positive, so I know R is going to be, I don't know, I'd say 0.8, just to make something up. Let me stop for a second. So R is a measure of how strong the relationship is. Just looking at these numbers, there is a relationship. But is it really strong? Is it? No, it's not crazy strong. Maybe. Okay, so somebody who was here last time, what do I do now to calculate all the crap I need?
I equals stat plot.
Stat, no. That's to plot it. I want to calculate this stuff. So maybe stat.
Yeah, y equals.
I'm not there yet. I don't have anything to put in there yet. Stat. I'm going to calculate the line of best fit in R.
Calculate
I'm going to, yeah.
first bar. Wait.
Nope.
Number 4.
4.
Yeah.
I don't know if you guys know. Anyone know what ln is?
Linear.
No.
Line.
Natural log.
Oh.
Logarithms?
Ew.
Yeah, do we want to,
God.
you want to, no. So in general, we focus on straight line correlation. But you know they could have parabolic correlation. They could have cubic correlation, right? And they could have quartic, and then they could have logarithmic correlation, they could have exponential correlation. Holy shit. It's just what shape do the points seem to kind of create? We're focusing just on linear correlation, but just in case you go into some field where this works, there are all kinds of other correlations you can make. So number 4, I already talked about why number 8 exists. The answer is I don't know, but we just use number 4 to get a line. Make sure you got L1, L2 in there if that's where you put your data. And then go down to calculate. And let me know if you don't get all of these showing up. Anybody else?
Says invalid dimension.
Your lists aren't the same size. So you're missing the R's?
Yeah.
Okay. Anybody else missing the R's? Okay. I was going to either do it. Okay. So both of you guys, you ready? You're going to all have to do. Is this your calculator?
Yeah.
And that's yours? Sweet. You only have to do this once. Hit second 0. All right. You guys remember doing this before? Then you're going to hit the button that's got a D on it, the x to the negative 1 button, to get to the D section of the list. You guys, you doing okay? So then go down to Diagnostic on. Got it? Enter. Enter. Sweet. Now go back, stat, calc, number 4, blah, blah, blah. And now you should have R showing up. Sweet. And by doing that, I just screwed up nothing. Doesn't change anything. I don't know why they make a switch. Too bad for us. Everybody cool with that? So I was way off. I normally am way off when there's such a small sample. It's almost perfect. Holy shit. If we graph this, we're going to see why. So that's what Abby is trying to get us to. We can do that now. Abby, write down the equation for me. What's the equation of the line? Somebody write it down for me. I'm going to get it from you later. So 0.436 x plus, in this case it's going to be minus 26.154. I like it. So somebody write that down for me. So now let's do, Abby's like, catch up to me. Everybody hit the y equals button. And we can put that equation in. You take that one out, go away. Make sure all the other y's have nothing in them. All right, somebody remind me, what was it?
0.436.
436 x minus what was it, 26?
26.154.
Huh? Wait.
26.154.
Oh, 26.154. Okay. All right, how's everybody doing? Let me know. You guys all right? Yes.
I'm still stuck at this part. I have all the numbers there.
Oh, so if you do L1, L2, go to. Oh, you got extra shit in your percent. Oh, you put the letter L in there. Okay.
Right.
Go to. Oh, okay. So many things. Okay. So let's try this. Stat count number 4. Now watch. You don't put L in one. You put second one. You get
Oh,
L1.
here you go. Oh, it was right there.
Oh, so somebody freaked you out. Now you talk.
Right here in the middle.
Whoever had this guy there before you messed you up.
So like after you grab.
Little booby trap. How's everybody else doing? You guys all right?
Yeah.
Yeah. Now, if I hit graph, probably not going to see shit. How's everybody doing? You guys all right? Graph, that seems to be very anticlimactic, but the calculator does what we tell it to. We didn't tell it where to look. So who remembers what button do I press? Zoom. Number 9.
Mine said did it and then it says quit.
Is who do I?
It did it and now it says quit.
Put go to. Go to. Yeah, go to. The next option down. And it puts the cursor on the problem. See, there's shit in there, so you want to get rid of it. The shit. Get it clear. Get it clear. Get it clear. Okay, now try it again. Sweet! Is this one? Sorry. Oh. What's that? Oh, quit. Window range. Oh. So do you, wait a second. L1, L2, I like it. Oh, your stat plot is not turned on. Turn that on. Now hit zoom. Sweet. You probably have the same issue. Oh yeah, hit second stat plot. And hit enter for the first plot. And we're going to change it to a scatter plot. Yeah, on a scatter plot. I hit zoom now. You just hit 9 too. Sweet. Yours is fast. All right. Everybody else all right? Yes. What? Oh, and hit zoom 9. Let's see what it says. Oh, so your stat plot's probably not turned on. Poor little dude. Yeah. So hit enter. Turn that on. Now do zoom 9. Zoom. And 9. Oh, you just hit the number 9. Sweet! Oh. Oh, it's second y equals stat plot. And turn the first one on. On. Just hit enter. Now hit zoom. Oh, wait a minute. Go down. Oh no, I think that's alright. Hit zoom 9. Let's see if that works. Oh shit. I see what it's doing. Somebody was doing really neat stuff with this. So I go back into plot when he wants scatter plot. Yeah. And there we go. 9. Sweet. Oh. Did you put it in? I think, is it trying to do it? It's really having some issues. Poor little dude. Let's see if there's some extra crap in here.
It's supposed to be plus, but yeah.
Man, your calculator's slow. Is that right for me to say that? Yeah, something's wrong with the calculator. What the hell? It is having some issues. There it goes. All right. Hopefully the issues are temporary. Zoom. 9. Let's see what it says. Okay. So your stat plot is not turned on. Second one, stat plot. Hit enter for the first one. Turn it on. Just hit it. Now do zoom. Hit the number. Yeah. Sweet. you see, you want everything, this doesn't matter. You want all these on the left side highlighted. All the other things are really freaky shit. Alright. So, hopefully, one thing you've learned about college is to speak the shit up. So if you're doing a test and your calculator is doing funky shit, just come up to me. Come up to see me. If I can't figure it out, I'll give you another calculator. It's crazy. Give it to you. No, I'll let you borrow. All right, so can you see visually why R was so close to 1? Because all the points are really close to the line. There. So when we talk about the strength of a relationship, it deals with how close the points are to the line. The further they are away from the line, the closer R is to... No, the further away from the line they are, the closer R is to...
-1.
0.
Oh,
What does -1 mean? They're right on the line, but the line is going...
this ending.
From your perspective, this way. Right, so 0 means... Doesn't that make sense, Paul? 0 means no linear correlation. 1 is perfect positive, -1 is perfect negative. It's craziness. So, you guys do this. There's a side that says side 1. Huh? Yeah, I gave you 3. I didn't give you 3.
So we're doing side 2 now?
Side 1. Do the third side.
So, will it always be obvious when if it's strong, not weak? Or is there-
Notice, everybody look at part B. Question B. Do you see how I gave you? And see, everybody get the one that says side 1. It's got bachelor's percentage and the amount of income, right? And it says side 1 at the top. Look at part B, question B. You see how I gave you what I promised I would? All right, so that's one thing. So just to have correlation, R has to be bigger than 0.482. Okay. So if it's below that, no correlation.
Oh,
If it's 0.49, weak correlation. If it's 0.87, strong correlation. Weak, strong. I forget what this one comes out to be, but we'll see.
oh, so 0.49 is weak.
Why? Because it's right above what's required. 0.49 is closer to 0 than it is to 1, and it's just above the minimum that was required to show any correlation, so it will be weak.
If it's 0.5, is that strong?
No, it's still weak.
Oh,
I can lift 0.49 grams. I can lift 0.5. You're both weak. Yeah. By the way, this might be too late to say, but you can either change the percentages to decimals or not. I'm not going to. I don't want to deal with decimals, so I'm just not going to change them to decimals. Nah. Gather. Craziness. So my suggestion is every now and again, as you enter things in L2, make sure they're lining up with what they're supposed to line up with in L1. So you don't get to the bottom of the list and they're not the same size. That makes sense. Appreciate you guys containing your excitement. You know, data entry can be very intense. So once you get all the data in, go ahead and try to do what we did a minute ago. We got the instructions on that one sheet.
Oh, it's super interesting.
It's true. Sweet. A couple. Yeah, that's fine. But this, you're missing, where's your plus y-intercept? Right, y equals x plus b. You got your ax, and that's your plus b. Oh, okay, okay. You're still in the middle. I got you, I got you. All right, let me see what I get. Let me try to catch up to you guys here. Are you guys getting this here? Always makes me feel a little better. I'm human, I can mistype things just as easy as anybody else. What kind of correlation is that? Is that strong? Keep going. Strong. Positive. So let's write down this line of best fit. Borrow this pencil. Yeah. So y equals 1570.74x plus 12231.47. Whew. Now, if you put your numbers in as decimals, you should still get the same numbers, just different decimal places. Hopefully, obviously. Right? If you put your numbers in as decimals, it comes out a little bit worse. R is 0.924, kick ass. So we blew this test out of the water. Let's zoom out there, Jeff. There you go, buddy. Let's move that thing. Here we go. All right. So obviously, is there correlation, period? Hell yeah. We blew this shit. And it's definitely strong positive, like we said. I like it. Strong positive. What does it tell us about the line of best fit? There's actually two things you could say there. I'm just going to leave it up to you. What do you guys think I want there? What does it tell us about the line of best fit? Holy shit, let's try to see this. Look at that, kids. All right.
That when the percent goes up, the median income goes up.
Can't say that. See, this kind of test doesn't know what causes what. So if you had more money, could you take more classes? If you had more money, could you take more classes? So is it possible that an increase in money would increase the bachelor's degrees? Is that possible? Yes. Now obviously it seems to make more sense that if you have more bachelor's degrees, that leads to higher paying jobs, but this test can't say shit about that. So two things you can say. R is really close to 1, which means the data points are all very close to the line. Yes. Or you could also say this: I would trust the line to make predictions. A strong correlation. I would trust the hell out of this line to make predictions because it's a really strong relationship. All right. So you can say one of those two things. They both basically say the same. So the data points are all very close to the line. Unknown data points are more likely to also be close to the line. There's evidence for that. So did I give us all the states? No. Right? I didn't give us all the states. So if I put a state in there that's not on the list, I could predict and then see if my line does work well with that prediction. And from what I've seen, it looks like it should. Let's see. We can either say 1, points are all close, 2 line, or you can say 2, I will trust the line to make predictions, blah, blah, blah. That's trying to say points. There you go. Predict the median income for a state with 37.6% holding a bachelor's degree. What is that, X or Y? What is that value? Is it X or Y? How do you know that? Because this is an X, Y table, Jeff. So these are my X's. What you put in L1 is considered to be the X variable. So if I make X, I'm going to leave it as 37.6. Why would I do that weird shit? Because I constructed the equation to work with percentage numbers. If you put yours as decimals, you better change that bad boy to 0.376. Now what do I do with this? To predict the income. I put it in the equation. I got this equation. So there must be some purpose to that equation. And the first thing you can do is make predictions. Put in the value of X or Y. It can predict the other guy. So if I put in there 37.6 for me, it should predict what that state should make. Let's see, 1578.7. So I get that. Yeah, cool. Yes, no, maybe. $71,291. And don't forget the 29 cents. Compare that to Virginia. Why am I comparing it to Virginia? Because Virginia had that. So I can see exactly. So this is theoretically from my line of best fit what they should make. Does Virginia make close to what I predicted? Yes. Why is it so close? Why was the prediction so good? Why is that prediction so good?
Because R is super close to 1.
R is freaking strong as shit, right? It's 0.924. If I see this kind of R for something I'm just doing out in the wild, that's going to freak me out a little bit. I mean, that's strong as all hell. All right. I will be honest with you. If you put all 50 states, I think the R is like 0.7. I did cherry pick a little bit because I promised you I would try to make the R's come out really obvious. Is it weak or strong? Not is sort of weakly strong, or you know. So I wanted this to come out really obvious. Do your results mean that if you get more people in a state to get a bachelor's degree, that the income will go up? Is that what they mean?
No.
Nope. We have no idea. I just know that right now, the states with higher percentage of bachelors happen to have a higher median income. I have no idea what affects what, if there's some third thing that affects both. Right? And if I just start doing like California wants to do, just giving degrees out to everybody, that doesn't mean that our income's going to go up because you're not going to know shit. Oh. Yeah, how you guys doing? Is this difficult? If I were one of you guys, I'd be like, okay, compared to hypothesis testing, this is kind of awesome. The only bad thing is the calculator. All right, let's try to get this. Did we get this graphed? I forgot already. No, yes, no. Let's graph this bad boy. I got to put in here 1570.74. And if I hit graph, I get nothing. What did I forget to hit? Zoom? Well, I got to let this guy finish. Zoom 9. Kick ass. So that's why it's 0.9 something. That's pretty good correlation. This, if you weren't here last time, this is what you're going to have to come up and show me. I'm going to have a problem with the final. You got to do it in your calculator. You got to come up and show me the calculator. Show me this. And that's where I can help you.